And here is the long-awaited episode with the Bukhanka, in which we've made some pretty good progress. Specifically, we came up with some very interesting step seals and connected the electric motor to the gearbox. But let's take it one step at a time.
Hello friends, I'm glad to see you in the new episode of Bukhanka. It's been a very long time since the last episode. Why is that? Well, because the current realities make their own adjustments and it's hard for us to get certain parts, but we still managed to do it.
Now, let's talk in a bit more detail about what we've managed to do and get our hands on so far. The last Bukhanka episode came out 8 months ago, and it was filmed in the old workshop. Fortunately, the new workshop is located very close by. And this is the simple way we're transporting the Bukhanka. As you can see, the wheelbase of our project is a bit wider than standard. That's why we took off the front wheels, just to somehow fit the Bukhanka onto the dolly. At that time, there was no driveway into the workshop yet, but there was a high ramp. And at this point, Kolya's Jiguli just isn't enough. We had to order a crane truck. 5 minutes of work, and the Bukhanka is in its new home, which means we can get started.
We took out the kit so that in our Bukhanka project, the side steps would extend out, just like on a car where the step comes out when you open the door. That's exactly the kind of idea we really want to bring to life in our project, you know.
So the package from the guys at BGT has finally arrived. They make cool stuff, tuning and all sorts of things. Basically they do everything. And among other things, they make these awesome retractable side steps. Those leaving, it doesn't matter. And so they sent us this kit so we could install it on the Bukhanka. Now we'll show you what it looks like. Basically there are a ton of different fasteners here. I don't quite understand yet what goes where, but the principle is extremely simple. So this kind of mechanism with a drive is installed under the car. The running board itself is attached to this bracket, and when you open the door, a signal is sent that the door is open, and this thing happens. That's it. The running board extends, you step on it, get into the car, close the door, and it retracts back. This is a fully complete system, meaning it comes with a control unit, all the fasteners, connectors and wires. So it connects and is paralleled with the door opening signal. A bunch of wires. It's not clear what goes where, but I think we'll definitely figure it out.
So, what do we have here? We have some brackets, we have several mounting plates, and now at this stage we'll have to try everything on and carefully check how it all fits together. Most likely we'll have to cut all of this, or at least make some adjustments.
As Valera predicted, that's exactly how it turned out. These plates are designed for installation on a specific range of car models. And of course our dinosaur is definitely not on that list. That's exactly why we're taking apart what the guys so carefully and meticulously assembled. What can you do? That's the job.
This is an intermediate stage. I've cut off all the unnecessary support points from these brackets. The universality that was offered to us doesn't suit our needs, because just for a moment we're dealing with technology from the future, and the design engineers probably weren't thinking about the future. That's why we removed everything unnecessary. We only need these supports. The plates we now have, let's call them bare, will be mounted here, and these plates themselves will be attached right here. This will be our right side, so that the motor is farther away from the wheel. In other words, this is the front of the car. The second part of the drive will be on the left side. There is absolutely no play in any of these joints. I think everything will be just fine.
Jumping ahead a bit, I can say that Valera was right here too. Everything really did turn out fine for us. First of all, we attached the mock-up of the future cladding, since the threshold will be hidden inside it. In other words, it will be almost invisible. And after opening the door, a convenient step slides out. Once we've decided on the placement, we attach the mechanism to the platform. Then, for convenience, we place it on a jack, position it, and tack weld it in place. Finally, the long-awaited first test. We connect the wires to the battery, and now you can clearly see how it works. We check the placement, the angle, and the extension of the platform. We were satisfied with everything, so we can move on. In parallel to this platform, a similar one is welded into the other corner, which will hold the mechanism to ensure that the long step is securely fixed and operates properly. next step is to connect the two platforms using a single solid rigid step. Obviously, the standard mounting won't work for us. By making the surface as simple and flat as possible, it will be much easier to come up with a rigid mounting solution. At this stage, we needed to figure out whether the idea would work at this length and with all the modifications from the factory design. And before building a serious structure, we attach a metal angle bracket to the platform. We hook up the wires again, and miracle of miracles, everything worked. All that's left is to adjust the offset a little, and then we can confidently weld everything together, since the two platforms are perfectly parallel and the mechanism works great. Here we didn't skimp on welding or metal, because rigidity is extremely important in this case. After everything has been welded and cleaned, we degrease and paint these platforms. Next, instead of a narrow metal angle bracket, we need to make a wide, sturdy step. In the end, it took just under 4 hours, Valera. By this time, Valera had welded the final step, and on the freshly painted platforms, we attach the mechanism, put the step in place, and assess the result.
Here's the intermediate result of our step. This is how it looks right now. I think it actually turned out pretty well, all things considered. But guys, the Litex team wouldn't be the Litex team if there wasn't a catch.
Honestly, I was really worried that this task would be too easy for Valera, and that he'd get bored standing still, not growing.
Nah, that's really just way too fast. So the guru of creative thinking showed up Sashka, Sanek, Alexander, all the same person. And he said, Valershik, everything's good, of course, but no. But no means that we have to redo all of this. What does he want? He wants this step to blink beautifully, to slide out, and then for a second step to slide out from inside it. In other words, one step isn't enough for him. He enjoys making things difficult for people. So now, from one step, another step will slide out. There's no limit to Alexander's creativity, so we'll have to keep finding ways to deal with these situations. This is what our finished footrest looks like. So, what work was done? The first footrest was made, but as we remember, Alexander said, Valerik, this is all nonsense. One footrest isn't enough for us. Let's make two. We're making two footrests. Fortunately, the kit we have for retractable footrests is designed for installing two footrests on the vehicle. So we installed both of them on one side. Accordingly, regarding our kit, the entire electronic system is powered by the vehicle's onboard network. In this case, we have a battery. So, moving on, we have two control units. One of them powers the motors, but it receives its signal from the other unit, which is also powered directly from the onboard network and receives a signal from the button. We implement the button as a sensor, which will send a signal to the unit and open our step. So we connect our battery. Our control unit is now loading, and this is roughly what it looks like at this stage. Next steps, we want to illuminate this nicely. It will light up, glow and blink. Basically, it will be almost like fireworks coming out of it. This will be handled by Guru of Contact Science, Alexei. We're now carefully starting to laminate our seal blanks with carbon fiber by hand. We need to make good scoring marks so that the carbon fiber adheres well and has excellent adhesion. In this case, we'll be sanding with 80 grit sandpaper. surface, and everything is almost ready for gluing the carbon fiber. But we need to take into account the fact that there are large gaps between the fiber weave. To prevent this from ruining the look, we need to paint this surface where we'll be gluing, so that when the lighting is turned on, it doesn't shine through and create an unattractive effect. Whenever you laminate with carbon, the base should always be black. And another important point, on the edge, we'll be attaching an addressable LED strip. So under absolutely no circumstances should we paint the edge, it really needs to remain transparent. That's exactly why we tape off the edge and simply spray the surface with black paint. Or actually not with spray paint. The material, you need to be as careful as possible. It's better to work in some kind of soft rubber gloves so you don't snag the fabric, since the fabric isn't held together by anything and its weave is very delicate. In other words, you could snag it, damage it, the pattern could unravel, and then it won't look good anymore. So be as careful as possible when unrolling and rolling up the roll.
For cutting, it's actually very convenient and practical to use masking tape. This tape holds and bonds the fibers together securely, helps to prevent any snags or fraying, and ultimately makes it very easy and straightforward to cut along. Now we cut right along the center of the masking tape. Pieces I showed you don't fall apart only because they've been soaked with glue. You only need a minimal amount of glue so that it doesn't interfere with the proper resin impregnation during carbon fiber lamination. We'll lightly soak it with glue, like this. We thoroughly soak the back side of the carbon fiber, which is the surface that will be glued to our workpiece, to make sure that the adhesive does not seep through or affect the visible appearance of the finished piece. This step is important for maintaining a clean and professional look. Next, apply the resin in a thin, even layer, carefully spreading it out with a spatula to cover the entire area and ensure a smooth, consistent coating. As you can see, we are placing the carbon fiber onto a thin layer of resin. The resin was poured over black paint, which we use to paint the clear acrylic sheet. This particular sequence is very important. Very soon you'll understand why. The next step is to evenly saturate the carbon fiber around the entire perimeter, but do it as carefully as possible, since the fabric is very delicate and it's easy to create snags that will ruin the appearance. And since in our case this is purely for decoration, we don't want any snags. The next day the resin had dried, and we could cut off all the excess, as you can see on the screen. The next step is to make a symbolic border out of tape around the entire perimeter. This is done in order to laminate the carbon fiber with a thin layer of resin. While Andre was working on that, we drew up this design for the overlay something in a cyberpunk style. I think it will fit perfectly into the design of a car from the future. A couple of days later, when the resin had dried, we transferred the drawing directly onto our semi-carbon overlays. We did this using a CNC machine. At this stage, it was very important to set the correct engraving depth, otherwise we wouldn't achieve the intended effect. What's the idea here? An LED strip will be attached to the edge of the acrylic glass. The transparent acrylic is laminated with light-blocking carbon fiber. As a result, only the parts we've engraved will light up. But
But obviously, just leaving the engraving as is isn't an option. So we fill the entire recess with slightly tinted resin. When it dries, it shrinks just a little bit, so we poured in plenty of resin to compensate for that. And to avoid spending days and days painstakingly sanding down all the excess, we carefully level it off, of course, only after the resin has fully dried. And I have to say, laziness really is without a doubt the true engine of progress. In the end, leveling took just a few minutes, whereas sanding would have taken at least half a day. And even then, we still wouldn't have achieved this result, namely a perfectly smooth surface. Now all that's left is to prepare it for painting, or rather for varnishing, and then put it on the threshold. Andrei took care of this part.
In the end, we decided to use matte varnish, because it's practical, simple, and overall, I'm not really a fan of gloss. So that's exactly what Kolya started working on. Or more precisely, all this time he was disassembling the box that came to us along with the electric motor.
So it's time to talk in a bit more detail about the technical side of our Bukhanka, specifically what will actually make it move in just a moment. As for the motor, we chose one from a Nissan Leaf. We picked it because its design is well studied, the motor is popular, all its issues and the solutions to those issues well known. The torque will be transmitted to the rear axle by an automatic transmission from a Mercedes. We chose this transmission simply because we have it. It was given to us by our subscriber Zhenya, for which we are very grateful. He gave us not only a box but also many other things which we will tell you about later. The electric motor and the automatic transmission will be connected using an adapter plate, which we designed, drew up and sent to the factory for production. From the factory we received a set of parts like this. This is the flange for the automatic transmission. It will be installed like this. This is the flange for the electric motor. It will be installed here. The two flanges will be connected to each other using this kind of adapter plate. Because the thickness of the adapter plate itself is quite large, and making it entirely out of metal would be, well, completely impractical. The actual physical connection between the electric motor and the transmission will be made using this kind of adapter. It was carefully constructed from the mating part of the electric motor shaft, which, as you probably remember, we took from a leaf reducer, as mentioned earlier. It was modified and manufactured from the original leaf reducer. The spline part is installed where it originally was. This is all factory made, and this welded flange rests right here, and everything is centered, all the fits are precise, everything is done properly. Subscribers of the Telegram channel have long seen the inside scoop about the motor and the transmission, and in the comments there was a bit of a discussion about whether the transmission could handle the electric motor and whether we even needed the transmission at all. That's not quite true. First of all, it will hold up because it's taken from a 3.2 DCI Mercedes engine, which from the factory has around 194 horsepower and 470 Newton meters of torque, whereas the Nissan Leaf motor has about 120 horsepower and 280 Newton meters of torque, so our gearbox has a safety margin. The second point is that we don't need a box. Well, that could also be considered true. But after much consideration, we really simply couldn't come up with any other truly practical solution to transfer the torque to the rear axle, where the differential is located in a way that isn't makeshift and also keeps costs minimal. The most reasonable solution is to transmit it through the classic layout using the gearbox and driveshaft. It really doesn't make sense to change or convert the rear axle to an independent suspension. We shouldn't forget that this isn't a passenger car and it's not a small minibus with an axle and leaf springs. This is the simplest design, which most certainly has the right to exist in this context. The options that have been suggested are interesting, but they are either too expensive or too complicated to operate and use.
Before installing the seal covers, we glue an addressable LED strip into an aluminum profile. The strip will be controlled by Arduino, which means we can have all sorts of different modes and functions. For now, we've gone with the bare minimum, but we're really interested to hear your ideas. How would you program this kind of lighting?
We quickly put on these two covers just to give you a visual idea of how it's going to look. We're not attaching them permanently, just putting them on for now, because soon we'll need to take them off as we'll be working on the body and the cover, and otherwise everything will get dirty, damaged, and lose its presentable appearance. So we put them on, showed them to you, took them off, and now we can keep working. In the end, we experimented a bit more, and Lesha installed a clever sensor that's supposed to react to the beat. In theory, this light show should sync with the bass and beats. It also reacts to tapping your foot. It looks something like this. I don't know why we need this feature in the door seal, but it looks cool, really. Thanks for watching, and may you have good vibes and a trusty axe.
Сработало, блядь! Никто не верит, блядь.